Imagine a world so strange yet so captivating that its surface might sparkle with diamonds, a planet where temperatures soar beyond anything we can fathom, and the skies are ablaze with fire. This is 55 Cancri E, often referred to as the Diamond Planet. But is this world a cosmic treasure chest or an uninhabitable inferno? Let's dive into what makes it so extraordinary. Located about 40 light-years away in the constellation of Cancer, 55 Cancri E was discovered in 2004. It is a super-Earth, meaning it's larger than our planet, but smaller than gas giants like Neptune. What makes it so intriguing is how close it is to its parent star. In fact, a single year on 55 Cancri E lasts just 18 hours, as it orbits its star at an astonishing speed. The planet is locked in a tidal position, with one side perpetually facing the star and the other cast in eternal darkness. The temperatures on the sunlit side of 55 Cancri E can reach over 2,400 degrees Fahrenheit, about 1,300 degrees Celsius, making it one of the hottest exoplanets we've discovered. The reason it's called the Diamond Planet stems from its chemical composition. Scientists believe its interior may be rich in carbon, and if conditions were just right during its formation, the immense pressure might have turned some of that carbon into diamonds. In fact, estimates suggest that a third of the planet's mass could be diamond. Imagine that, a world so filled with this precious gemstone that it could eclipse every diamond on Earth. However, the reality of this planet is far from glamorous. Unlike Earth, which has an atmosphere capable of supporting life, 55 Cancri E's atmosphere is likely filled with toxic gases such as hydrogen cyanide and methane. Combined with the searing heat and radiation from its nearby star, it creates a hostile environment. Picture standing on a surface hot enough to melt metal, with volcanic eruptions possibly occurring across the landscape and no night to offer relief from the perpetual glare of the star. It's hardly a paradise. Still, there's something incredibly fascinating about this planet. It challenges our understanding of how planets form and what might be possible in the universe. Could other planets like this exist? Could they truly have surfaces glittering with diamonds, or is that merely a metaphor for their chemical composition? Does 55 Cancri E sound like a sparkling wonder or a glittering nightmare? Let us know your thoughts in the comments below. In the following section, we'll delve deeper into the planet's fiery landscape and ask a pivotal question. Could life, even in the most extreme forms, ever survive on this alien world? Stay tuned. Could 55 Cancri E be a fiery inferno hiding a dark secret? While its reputation as the Diamond Planet might sound glamorous, the reality of standing on its surface, if you could survive, would be a nightmarish experience. The conditions on 55 Cancri E are among the most extreme in the universe, making it both a fascinating and terrifying place to imagine. Let's first consider the heat. On the side of the planet that faces its star, temperatures reach an almost unimaginable 2,400 degrees Fahrenheit, 1,300 degrees Celsius, hot enough to melt most metals and reduce rock to liquid. Scientists believe that this side might be covered in vast oceans of molten lava, glowing red and orange like a never-ending sea of fire. The air above this blazing surface would shimmer with heat, distorting any view and making the very idea of standing there utterly impossible. And remember, there is no nightfall to provide respite. The same side of the planet always faces its star, trapped in eternal daylight. Meanwhile, the dark side might be slightly cooler, but still far too hostile for any form of life we know. The atmosphere adds another layer of chaos to this already hellish world. Observations suggest that the air is filled with toxic gases like hydrogen cyanide, deadly to humans, along with methane and possibly carbon monoxide. The extreme temperature difference between the day and night sides likely generates violent winds that tear across the surface. Imagine hurricane-force storms, carrying heat and toxic chemicals, sweeping across an already volcanic landscape. It's a scene straight out of science fiction, but it's very real. So how do scientists study a place like this? Clearly, no spacecraft is going to land there anytime soon. Instead, they rely on telescopes and computer models to simulate the conditions on 55 Cancri E. Using instruments like the Hubble Space Telescope, scientists analyze the light coming from the planet and its star. As this light passes through the planet's atmosphere, it reveals clues about the planet's chemical makeup. To test their theories, researchers replicate these extreme conditions in high-pressure labs on Earth, using powerful equipment to mimic the heat and pressure found on 55 Cancri E. Through these experiments, they've begun to unravel the mysteries of its molten surface and toxic skies. If you were to somehow stand on 55 Cancri E, protected by an impossibly advanced suit of technology, it would be an utterly alien experience. The ground beneath your feet might be a shifting, glowing mass of liquid rock. The air would be thick and shimmering with toxic gases, and the light from its nearby star would blaze relentlessly, casting sharp, dramatic shadows across the molten landscape. The heat would be so intense that even the strongest materials we know would quickly break down. It's a world so hostile, it's almost poetic in its danger and beauty. Could life, as strange and resilient as it may be, survive on such an extreme and mysterious world? While 55 Cancri E might seem like the ultimate definition of hostility, life on Earth continues to surprise us. We've discovered organisms called extremophiles, which thrive in environments once thought to be inhospitable. Deep in the ocean, around volcanic vents, in acidic hot springs, and beneath miles of Antarctic ice. These organisms redefine what it means to be alive and push the boundaries of what we thought possible. Could something similar exist on 55 Cancri E? Life on such a planet would need to be almost unrecognizably different. The extreme heat, radiation, and toxic gases would make it impossible for Earth-like life to exist. But what about life as we don't know it? Scientists speculate that alien microbes might evolve mechanisms to adapt to intense heat, using chemical processes entirely unlike anything we've seen on Earth. Instead of relying on water, which would vaporize instantly on the sunlit side, these organisms might use molten rock as a medium or extract energy directly from the planet's lava oceans. Alternatively, on the dark side of the planet, where temperatures are lower, there might be regions in the twilight zone, where day meets night, that are more stable. If life could anchor itself in this narrow strip, it might exist in forms we can't yet imagine. It's not impossible, and in a universe as vast as ours, stranger things are bound to exist. While the chances of life on 55 Cancri E seem slim, the idea that life could find a way to survive in the most extreme environments drives scientists to keep searching. If we've learned anything from Earth's extremophiles, it's that life can persist in the most surprising places. Could 55 Cancri E harbor alien survivors? It's a thrilling possibility, one that reminds us of how little we know about the universe and the incredible adaptability of life. What do you think? Could life, no matter how bizarre, find a way to exist on such a fiery, hostile world? Let us know your thoughts in the comments. In our final section, we'll explore what planets like 55 Cancri E teach us about the diversity of worlds in the universe and our search for meaning among the stars. Stay tuned. From light curves to spectral fingerprints, we've developed incredible tools to study distant worlds. But when it comes to answering the big question, are we alone in the universe? How close are we really? Planets like 55 Cancri E may be tens of trillions of miles away, but thanks to groundbreaking technology, we're starting to unlock their secrets. When you hear that scientists have determined the temperature, composition, or even the potential atmosphere of a planet located 40 light-years away, it sounds almost magical. But it all starts with light, the faint signals a distant planet reflects or emits. One key method astronomers use is called the transit method, which occurs when a planet passes in front of its star, as seen from Earth. During this transit, the planet blocks a small fraction of the star's light, creating a dip in brightness. By carefully analyzing these light curves, scientists can calculate the planet's size, orbit, and how close it is to its star. For a world like 55 Cancri E, this method tells us that it orbits extremely close to its star, completing a full year in just 18 hours. But studying a planet's size and orbit is just the beginning. To figure out its composition, scientists use spectroscopy. When starlight passes through a planet's atmosphere or reflects off its surface, it interacts with molecules and atoms, leaving behind a unique fingerprint. These spectral fingerprints allow astronomers to determine the elements present on the planet, whether it's rich in carbon, filled with toxic gases like methane and hydrogen cyanide, or something else entirely. For 55 Cancri E, spectroscopy has hinted at a carbon-rich environment, which is why scientists once hypothesized it could be a diamond planet. However, studying distant planets isn't easy. The light signals are faint and often overwhelmed by the glare of the star itself. It's like trying to spot a firefly next to a spotlight from thousands of miles away. That's why astronomers rely on incredibly sensitive instruments, like the James Webb Space Telescope, to tease out these delicate signals. Even then, the data is limited. The farther a planet is, the harder it is to get a clear picture. For 55 Cancri E, which orbits so close to its star, the intense heat and radiation further complicate our ability to gather precise measurements. Despite these challenges, scientists are constantly improving their tools, and every new discovery sharpens our understanding. The study of exoplanets like 55 Cancri E reminds us of the incredible ingenuity of human exploration. We may be separated from these worlds by unfathomable distances, but the light they send us holds answers to questions we've been asking for centuries. Are there other worlds like ours? Could life exist elsewhere in forms we've yet to imagine? What do you think? Are we on the brink of finding life on other planets, or do we still have a long way to go? Let us know your thoughts in the comments. As we wrap up, let's reflect on what these discoveries teach us, not just about the universe, but about our place within it. Stay tuned for the final chapter. Would we risk exploring a world that could literally vaporize us, just for the chance of unimaginable riches? Imagine the sheer audacity it would take to send humans to 55 Cancri E, a planet so extreme that even stepping onto its surface seems like a death sentence. Yet with the promise of diamonds, energy, and scientific discovery, the idea is undeniably tempting. What would it take for humanity to survive, let alone thrive, on a planet this hostile? In a hypothetical future, technology would need to advance far beyond anything we currently have. For starters, just getting to 55 Cancri E is a monumental challenge. At 40 light-years away, even the fastest spacecraft we can imagine would take thousands of years to reach it. To make the journey feasible, we'd need technologies like warp drives, generational starships, or perhaps even the ability to manipulate spacetime itself. Let's say we overcome that hurdle and arrive on this fiery world. The real challenge begins on the surface. The daytime temperatures are so hot that they could melt most materials, so any spacecraft or base would need to be made of heat-resistant alloys beyond anything we've engineered. A human colony would likely have to avoid the planet's day side altogether, establishing itself in the cooler, darker regions. Even there, survival would require shielding against toxic gases and relentless winds. Why would we risk all of this? One possibility is mining. If the diamond planet theory holds true, the wealth hidden beneath 55 Cancri E's surface could be enough to fund generations of exploration. Mining operations might involve autonomous robots or drones, capable of surviving where humans cannot. These machines could dig deep into the planet's molten crust, extracting diamonds or rare minerals while keeping human colonists safely out of harm's way. Alternatively, we might focus on harnessing the planet's energy. The lava oceans and extreme heat could provide an unlimited source of geothermal power, perhaps fueling entire civilizations. Still, the idea of humans walking on the surface seems far-fetched. Maybe we'd rely on remote exploration, sending AI-powered probes to study the planet from orbit, where we can remain.